Prepare for a maths lesson, but hopefully it's not going to be confusing, because this one is going to help you build and design a safe off-grid electrical system. It is paramount that you can convert between volts, amps, watts, watt hours, amp hours, because if you can't do that, it's impossible to build a high quality safe system. So here's how you're going to do that. It's actually not that complicated. It all revolves around, like we said, Watt's law, and this little diagram here is going to help you. I'm going to teach you a trick about this triangle. If you are trying to figure out how many watts something has, you will need to know the volts and the amps. What if you can't remember that? Well, I want to find the watts, so I'm going to cover that up and look what's left. Volts and amps, they are the two things I have to know. Well, that's great, Rosie, but what do I do with the volts and amps? I'll tell you what you do. Imagine that there is a multiplication sign between these two. So I want to find watts, cover it up, and watts are equal to volts times amps. So let's write that down. Watts equal volts times amps. My pen's doing very strange things. That should be an L. There we go. Watts equals volts times amps. Okay, that's fine. What if we want to figure out, Rosie, what the volts are? What if I want to do that? Well, that's fine. Let's use the same little trick. So we'll cover volts. What do we need if we want to find volts? We need both watts and amps. But this is a different line up here. I want you to see that line as a division symbol. So that would mean that if we're trying to find volts, it's watts divided by amps. Let's write that down. Volts equals watts divided by amps. All right then, what if I want to figure out what amps are? Cool, let's use the same strategy. Cover up amps. So to find amps, we need to know watts and volts. And remember, this line is division. So now let's write down the little equation so we remember. Amps equals watts divided by volts. And they are essentially the three equations you need to know. A couple of other things you need to understand, but this is absolutely quintessential. So I recommend, if you're a visual person, draw out this triangle, yeah? Watts, volts, amps. Easy. That line is a division sign, that one's multiplication. If you're finding amps, cover it up. You go watts divided by volts. If you want to find watts, cover that up. And then it's volts times amps. You want to find volts, it's watts divided by amps. Pretty bloody simple. Groovy, baby. Let's have an example where we are finding watts. Let's think of a real world example. We're not going to do these maths problems where it's like, Rosie had 12 watermelons and gives 3 to Natalie. How many does she have left? Because that's not very likely. Let's think of my laptop charger. On every sort of bit of equipment you have, there will be writing on there that gives you some specifications. So let's find the watts. And remember, if we are finding watts, we cover up watts and we need volts times amps. So let's write that down. Watts equals volts times amps. All right, let me just look at my handy dandy charger here. It tells me that the output of this charger is 20.3 volts. So let's do this, 20.3 volts. And it says the amps are 3 amps. Okay, so 20.3 times 3 is 60.9 watts. And what do you know? Apple sells this charger as a 61 watt charger. Wasn't that easy? We had the volts and the amps, and that allowed us to figure out the wattage. What if this time we want to find the amps? To be able to find the amps, what do we need? Well, here's the amps. Cover that with your finger, little trick. To find the amps, we need watts and volts. And remember, this line here is a division line. So let's just write this down so we remember. Amps equal watts divided by volts. So in this example, I'm going to use my toaster. Now, every bit of electrical equipment will have a sticker on it, like this one here, and it tells me the watts and the volts on there. So the watts of this toaster is 800 watts. Now, volts, this toaster actually operates anywhere between 220 and 240 volts. We're just going to go smack bang in the middle, 230 volts. Okay, 800 watts divided by 230 volts will give us 3.5 amps. How easy is that? But there's something I want to bring to your attention with this. I've done that based on 230 volts, right? But if you are using your off-grid system, you are not using 230 volts, are you? You are using a different voltage, either 12 volt, 24 volts, 48 volt. So let's pretend you are using your 12 volt system this time. So instead of 230 volts, you are using 12 volts. So let's do the same. Amps equals watts divided by volts. So that would be our 800 watt toaster divided by, this time, 12 volts, because the battery system I have is 12 volts. Well, do you think the amps are going to be the same? No, they are not. Through a 12 volt system, it is going to pull 66.7 amps. And in fact, it would probably be a bit more than that, because there would be the inefficiency of the inverter that inverts 12 volt into 230 volt power. But can you see the difference in amperage there? The cables or the wiring you would need in a house would only need to handle 3.5 amps. But if in Australia with 230 volts, but if you are using a 12 volt system, your cables, your wiring needs to handle 66.7 amps. It would need much thicker cabling. So just bear that in mind as we get to future lessons. But for now, you just need to know. You pop in the values, the wattage and the voltage. And if the voltage changes, guess what? Even though the wattage is the same, the current changes, or the amps. Now we need to show an example of figuring out volts. Okay, this ain't so hard, is it? We've been doing pretty well. So do you remember what I said? We cover up what we're trying to find, in this case, volts. So we have watts and amps left. This middle line, remember, is a division sign. So watts divided by amps will give us volts. Let's write that down. Volts equal watts divided by amps. And the example I can think of is for maybe solar panels. Maybe you're buying them secondhand and the seller doesn't have all the details. They know the wattage of the panels and they can tell you how many amps it pulls in, but you're just not sure of the voltage. So let's figure that out. Let's say it is a 200 watt panel that you're looking to buy off this person on Marketplace. Hopefully they're being genuine. And they've said that it's rated at 8 amps. Okay, cool. So we want to find out the voltage of the panel. Well, all we need to do is 200 watts divided by 8 amps. And guess what that is? It is 15 volts. So should be enough to charge a 12 volt panel. Personally, I'd like a bit higher than that, but it is a 15 volt panel. So you know what? I might pass on that one. And if you had a 24 volt system, that ain't high enough. 48 volt system, definitely not high enough. But that's an example. To figure out the volts, all you need are watts and amps. And in fact, how about I prove it to you? Let's double check our maths here. Remember with the toaster, right? 800 watts, and we had 230 volts and 3.5 amps. So let's pretend we didn't know the volts. So the watts of the toaster was 800. The amps was at 3.5. Yes, 3.5 amps. We're going to go back. Divided by 3.5 amps. And that will give us, if we use our calculator, 800 divided by 3.5 gives us 228.6 volts. Basically 230. The reason that doesn't equal 230 is because this figure of 3.5 amps was rounded. So if I need to prove this to you, don't I? I know I do. So if we go 800 watts on the calculator divided by 230 volts, it gives us 3.47, blah, 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 blah. So then, if we go, we're going to use that number, copy that, paste it, and remember we needed the watts, so 800 watts divided by the amps, and would you look at that, 229.97, so 230 volts. Okay, you happy? You believe me? Yay! Happy little veggie minds! The last thing I want to talk to you about in this video, there's plenty more things to talk about, is actually watt hours and amp hours. We need to be able to switch between the two. Why, do you ask? Well, it's just a good thing to do, but also you might be looking at portable power stations. There's loads out there. They're really popular. For example, this Blue Eddy one that's rated at 204 watt hours. But you also might just be looking at a standalone battery, like a King's 100 amp hour battery. How do we compare these? They are in different units. Let's have a look. The Blue Eddy one is rated at 25.6 volts. That's what it says on the specifications. And remember, it also had 204 watt hours. Okay, now the King's battery is 100 amp hours and it's 12 volts. Let's start by doing some calculations on this King's one. This one's in amp hours, and we know that amp hours or amps change depending on the voltage. We saw that here with the toaster. At 230 volts, it was only 3.5 amps, but at 12 volts, it was 66.7 amps, even though the watts were exactly the same. So it is better to work in watts, or in the case of capacity, watt hours, than it is to work in amps. The calculations we need to do are pretty much what we had in our triangle earlier on. We were dealing with watts, volts, and amps. The difference here is we're now working with watt hours and amp hours. Same position, we're just now doing watt hours and amp hours instead of watts and amps. So with that in mind, let's figure out how many watt hours, or the capacity, that the King's battery has. If I cover that, right? Cover the watt hours, that's what I'm trying to figure out. We have volts times amp hours. Okay, cool. That's easy then. It's 12 volts times 100 amp hours, and that gives us 1200 watt hours. Holy dooly. 1200 watt hours versus 204 watt hours. That is so much bigger than the Blue Eddy. But if you didn't know this simple calculation, you might have thought, oh yeah, I don't know what they mean. 100 amp hours is probably, you know, about the same as a watt hour. So 204 watt hours is probably bigger than 100 amp hours. No, it's not. It is totally different. Totally different. Watt hours are comparable. That's the capacity. 1200 watt hours is 1200 watt hours. 100 amp hours at 12 volt is not 100 amp hours at 25.6 volts. Let me show you what 100 amp hours at 25.6 volts would be. So if we're trying to figure out what watt hours would be if we had 100 amp hours, we need the volts and we multiply them together. So 100 amp hours times 25.6, get this, look how many watt hours it would be, 2,560 watt hours. 2,560 watt hours, which is more than double this. So hopefully you can see how important it is to understand these calculations so that you are comparing apples to apples. The key here is an amp hour is not an amp hour. It depends on the voltage. You need more context. But a watt hour is a watt hour no matter the voltage. So it's best, in my opinion, to be working in watt hours when you are comparing batteries or the capacity of your portable power station. Remember that, because there will be more rants about working in watt hours versus amp hours when you are sizing your batteries. I know that was a lot. Hopefully it makes sense. It's a good thing there is a replay button. Hit subscribe because I'll be making lots more videos to take you from 0 to 100 to build the perfect system for you. I'll catch you in the next one.